now we will be discussing programming in Scala, and as you know that the Scala, the Apache Spark is developed in the Scala, and that is the preference that has been given by the Spark team is because of many benefits Scala provide over the traditional language like Java. And we will be discussing each and every aspect, and in terms of through this presentation what makes Scala is a language which we will try to do a little bit a comparative study where it make difference in terms of a few of the constraints. So sometime I'm not sure like this when we explain this language, sometime it looks basic, sometime it looks some things, so just bear with that, don't expect too much, but yeah, it's a plain concept we'll try to explain. So the thing is Scala is both object oriented and functional. It is blend object oriented functional programming in a statistically typed language. So what we are so that is the thing is that it is both, it is object oriented no doubt, but functionally you can define it. It is not automatic functional language, but you can define to work as a functional language. And now we will just a little bit look into the all object oriented programming. So all but the most trivial program needs some sort of structure that everybody knows, like why we do programming. We structure our code rather than writing into the assembly language. We provide a structure in a very high level language of our preference. Put data and operations into some form of containers. Make these containers fully general so that they can contain operations as well as data. So this that way they are themselves are also values that they can store and in the container or passed as a parameter to the operations. So these value can be stored as well as passed as a parameter, and we call these containers as the objects. So if you have terms in terms of like what is the object, which both consist of value and the operations, and this value can be passed or they be passed to the different as a parameter to the different operations. That was the basic concept of object-oriented programming. I remember now many language like admits value that are not objects, such as primitive value in Java, or they allow static field and method that are not members of any object. So that is like what we are trying to do, and we will try to solve a problem through the object over our procedural approach, which earlier language has, like Fortran, or if you will see, if you have worked in non-object oriented or the traditional C, or if you have maybe some of you might have experienced those non-object oriented programming languages, they are a little different. So, but when in the object oriented programming language, there are some flaws, like they cannot be, everything cannot be object. So these derivation from the pure idea of object oriented programming looks quite harmless at first. So we say like, okay, what is, it's the one or two things that cannot be confirmed to the object oriented way. But what happens is these things become complicated and limits the scalability when we are thinking of parallelize our operations that can run on a multiple memories and or the multiple cores. So that time we find out these things need to be addressed properly. That now what to resolve that, Scala is an object-oriented language in the pure form. Every value is an object. So every operation is a method call. So what does it says that, for example, when we say 1 plus 2 in Scala, what we are doing is we are defining a method defined in a class int and the new integer 1 dot plus new integer 2. So what we are saying, when you define these two things, we are defining the value in the object and the operation in the object. So that is the way we are defining into the Scala. So the way Scala is interpreting 1 plus 2 internally. Second thing is functions are first class values with the same status as an integer or a string. So you can pass functions as argument, return them as a result, or store them in a variable. You can define function without giving them a name. So when functions programming, and what are the ideas behind the function programming? So the only way you see that, like when you are defining the functions, you define them either pass whatever the value you wanted to pass. So in that the two idea which differentiate is you can pass function as arguments, return them as results, or store them in variable. You can define function without giving them a name. So what it will provide, no side effects, inputs are mapped to output, but no data is changed. Instead, new values are generated. Like string in Java, value are immutables. So the Scala encourages the functional programming but does not require it. So the next slide is why Scala rather than Haskell or Akmal or Ruby or Python or Groovy. There are so many language. Then why we are choosing only the Scala? So one thing is the compatibility with the Java. Compilers, it compiles to the JVM. But what is the same thing happens? Why didn't we choose the Groovy? That is also another language, and the JRuby. So what is we can do in interoperable with the Java code, Scala code can call Java methods. So what's the advantage which we have over Scala? First thing is we also learned about the functional programming which it can prefer over the object programming it can done, and there are the certain other things which is it can call Java methods, it accesses Java fields, inherits from Java classes, implement Java interfaces. Scala makes heavy behind the scene use of Java libraries. So if you see the example here, extend sum of the string how, string s is 1, 2, 3, and if we use the s2int function, and that is only possible because we is not defined any string and it convert to the rich string. So the implicit conversion happens. So what we are saying, it is very blend with the Java. You can so much of you can inherit or use the functionality of Java still while we are working on the Scala. Now the another slide which we shows that Scala is concise, and you can see this example is done perfectly to show that typically it saves the 50% of coding lines. And if you wanted to define a class or a function, so let's go in the Java side. We can start with the Scala. You define a class, my class. You define index int as one parameter, and text a name string is another parameter. So first thing is new my class, and you can instantiate that way. 3 and ABC. Now instantiate an object. Now if you come to the Java, you define a class, my class, you define private int index integer as index as an integer, private name as a string. So you define the two private variables. Then you define the methods my class int index or string name. So and then pass the value to initialize those. Now you define your objects to instantiate from that class. So if you will see the verbiage used in Java compared to Scala, which is using, you can simply do these things in 2 lines because instances, variables, and the constructor defined implicitly. So that's the beauty of Scala. It means it takes the overhead of defining everything which you are doing in Java. The second thing is Scala is high level. So for example, looping and those kind of operations which you have been doing in Java, for example, if you wanted to say that if a string is a uppercase or not. So if we see the boolean name has an uppercase and we define a variable false, then if you will go, then you have to loop every character in that string. So you go find out the length and you will start with the variable I and increment till the end of the string. So and then you will put a if loop, if character dot is uppercase and the name dot character at I, and if you find this value, then it means the name has a uppercase true. If not, you will break and then it will return false, and that way the false will remain. So this is the way you do the iteratively you can find out this. But the same thing, if you will come onto the left side, you see the value you define name dot exist, and in the curly braces you say is uppercase. Now we will just try to understand the simplicity and how it works. The exist cause is uppercase to be applied to each. So the exist function, whatever given to the string, the name string, it apply to all of them. Not like so the looping, it will exist will automatically do the looping. Elements in the name until one that satisfy is found. So each uppercase, when we see that each uppercase in the right side is a function being passed as argument to as an exist. So if you can see the functional, using this functional programming approach, how it makes life simpler to rather than writing the complete logic to incompetent of a Java. So means like it provide a high level construction of the things which you can do easily rather than writing a complex code. Now the next slide, Scala is statically typed. So strong typing is very important in functional programming. So most scripting language like Ruby, Python are dynamically typed, which is supposed to be one of their advantages. Statically typing making programming much safer, but sometimes the types declaration becomes a burden. Scala's type interfacing mechanism minimize the number of types declarations required. It is not uncommon for user not to have no explicit types. So the another thing is the Scala is REPL. The Scala REPL is the tool for evaluating expression in Scala. REPL is for read, evaluate, print, loop. So we will be when we will do some of the things which we will be understanding those concepts too. Now let's come back to the Scala variable type. So any language, when you start doing it, you have to learn the basics. And the first thing is the variables. First thing is every language has a list of variables, and the variable, the length, the value they can contain. So integer, you know, like has a 8-bit or 16-bit integer, and then they have a limit to store a particular value. So if you have gone to C, C++, Java, any class, they start with these things. So now let's go and understand difference of value and variable. Scala variables comes in two shapes: values and variables. A value variable is really just a constant. So now we are talking about value variable. Just a constant, meaning once assigned, you cannot change its value. It's a immutable. So immutable, we are saying the value variable, if we assign, we cannot change. Let me see if we still okay. Let me just go back to my view. Okay, now it comes. So you cannot change the value variable. However, the regular variable on the other hand is mutable, means you can change their values. And now how we declare those variable and values. So this is simply a declaration of two types of variable is like you start with where for regular variables, my value, colon, and then you give the type and any initialized value you wanted to give to that variable. And for value, you start with val, and the same way you can do that. The first variable, my val, is declared using keyword where. This means that it is a variable that can change value. The second variable, my val, is declared using keyword val, means value that is a value, a constant that cannot change value once assigned. Now we will talk about the Scala type inference. When you assign an initial value to a variable, the Scala compiler can figure out the type of variable based on the value assigned to it. So that is, I think most of the language do that, but some of them not. For example, Java, sometime I see like it might give some issues. This is called type interface. Therefore, you can write these variable declaration like this: value variable myvar is equal to 0. So based on the value 0 provided to the variable, it will automatically identify it's a number, not a string. And val myval is equal to 1, and that way it can easily identify based on the value. Now block expressions, and that is like this something which you need to see in terms of how this Scala is getting little deviated from the other languages. In Scala, a curly braces block contains a sequence of expressions, and the result is also an expression. So the value of a block is the value of the last expression. So this feature can be useful if the initialization of value takes more than one step. For example, if we see the example here, value, we are calculating a distance. We defined a distance dx of a dx equation where x minus x0 and value dy is equal to y minus y0, and then expression, result expression, what we are doing is a square root dx and dy x square plus y square. So the value of the curly braces block is the last expression. So when we identify the value, we initialize the variable, and then we are evaluating the distance, and the value will be the last expression. The variable dx and dy, which were only needed as intermediate values in the computation, are neatly hidden from the rest of the program. So this is the way we can just identify A100, B100, and A plus B. That is another example how we can assign it and evaluate an expression while doing in a block expression. So the curly braces, and you can just see, and then you can just have to remember that the colon is also there to just separate the first assignment, second assignment on the result set. Now we have one of the wonderful thing is the lazy evaluation. Most language are strict languages. They compute the value of an expression immediately. Some languages like Haskell are lazy. Every expression waits for its first use. Scala, on the other hand, is strictly by default. It is strict by default, but lazy if explicitly specified for given variable or parameters. How we can do that? How we can make it strict and how we can make that? We will see these two examples. The following Scala program will print foo, then bar. So if we see the value x, and we are printing a string foo with the expression 10, and now we are printing bar as a random string, and then we are printing the variable x. So what will happen? The first following Scala program will print foo first, then bar. It will print foo, then bar, then x, value of x, which is 10. So that will be the sequence. But what will happen in the case of lazy? If we say the lazy value x, print foo and 10. So what we are saying is that every expressions evaluate weights for its first use. So it means this the value of x, and this will weight when it is used. So it will print not the foo, but it will print the var. Then it will evaluate, means it is lazy. Now when you are going to print x, that time it will evaluate, and then it will print foo and then 10. So if you so you can see that it will print bar, then foo, then 10, since it delays the computation of x until it is actually needed, rather than printing upfront as you see in the first example. So a lazy evaluation can do some time to resolve some kind of a programming error. Now we will see the control structures in Scala. For loop is a repetition control structure that allows you to effectively write a loop that need to execute a specific number of times. So that loop is the plain concept, how we to perform many operations in a range. So syntax for loop with range, the simplest syntax for the loop with range in Scala is for variable x, and then you see the left arrow and then you define the range. Every language has this construct defined, but if you see here for variable x, left arrow, range, then you start with the curly braces and the statements, and again the terminator is the semicolon. So if you go here in this example, if you will see, there is a for loop and there's a which is 1 to 3 colon b 1 to 3. So it is the looping onto the two variable, then it is printing the value of a plus a and value of the b plus b. So this is another thing that is this function is doing, and now we will see it can also go through a range loop execution with the multiple filters. So we defined a list which is 1 to 10 numbers. So for a, then again in the num list, then we are also can evaluate if a not equal to 3 and if a is less than 8, then only the print value of a in the string value of a, and then which will giving the additional a value. So here the range could be range of numbers, and that is represented as I or to j, or sometimes like I until j. The left arrow operator is called a generator, so named because it is generating individual value of a range. So now that the value they are saying is the loop generator, called a generator. So that may be some language keywords which we need to be understand. For loop with yield. You can store return value from a for loop in a variable, or can return through a function. So to do that, you prefix the body of the for expression by the keyword yield. So you do the same way, return value for variable x, and in your generator symbol, then list if conditions, and yield in x. So that is the another benefit, how if you wanted to capture and pass the looping value to the another function or in a variable. Functions, and any language, when you start, first you go with the variable, then you go with the understanding some of the loops, for loops, control loops, and if and else condition. The next thing is the functions. A Scala function definition has the following form. You define a functions, then name list of parameters, return type, and then function body and return expression. It's pretty common, but the only thing is the way you define the parameters. So you have the name of parameters and return type, like int or something like that. A function that does not return anything can return a unit that is equivalent to void in Java and indicates that the function does not return anything. The function which do not return anything in Scala, they are called procedures. So either you return does not return anything, and this is where the definition of procedures comes. So if you say definition of print me unit is equal to, we can define a println hello Scala. So that is where people start printing the first program, like hello world and hello Scala, and everything is like that. So if you wanted to try out, just you can try that out on your Scala prompt. The other thing is, we will go into the arrays. Arrays are declaring array variable. To use an array in a program, you must declare a variable to reference the array, and you must specify the type of array the variable can reference. So definitely, now the following is the syntax for declaring an array and variable. So if you will see that variable z, then this is array of strings, new array of string of 3. So we can define this string like this, or variable z, new array string and 3. So we can declare the array of strings or array of anything which you wanted to define. So this is where we are saying to declare an array variable in the Scala. Now we'll move to Scala collections. Collections may be mutable. The content of the reference can change, or immutable. The things that can refers to is never changed. Now if you come to the list, Scala lists are quite similar to arrays. All the elements of list have the same type, but there are two important differences. First, lists are immutables, which means element of a list cannot be changed by assignment. List represent a linked list, whereas arrays are flat. So that is what the arrays. So what you are saying, the Scala lists are quite similar to arrays. All the elements of a list have the same types, but there are the two important difference between the arrays and the list. So now if we go to the examples of a list of strings, if you wanted to say the string value fruit list and string list fruit, and in the list we can have apples, oranges, pears. List of integer, if you want to define value, val, nums, list, integer, list 1, 2, 3, 4. And if you wanted to define an empty list, well, empty list, list, nothing is equal to list. So this is the way means we can define the collections. Now we go to the Scala Maps. Scala Map is a collection of key value pairs. Any value can be retrieved based on its keys. Keys are unique in the map, but values need to be unique. Maps are also called the hash tables. There are also two kinds of maps, the immutable and the mutable. By default, Scala uses the immutable map. If you want to use the mutable set, you will have to import Scala Collections.mutable.map class explicitly. Empty hash table whose keys are a string and value are integer, where a map character integer. So we defined a where a with a map type with the two values, character and a map. A map with key and values, value colors is the map red, and we are defining the hash like hash symbol for the red and azure, then defining the for that. So that maps we can define as a key value pair. And if you know, like if you have gone through the NoSQL databases, all the NoSQL database like Radish, or your memcache, all these are the key value pair. Even your HBase, those are all key value pair databases. So if you wanted to within your application you don't want to use any other database, you can create your own database with these maps and key value pair. Now there are the object oriented and functional programming. We will have constructors, singleton, companion object, case classes, inheritance, traits, higher order functions, map functions, filter functions, reduce function, flat map functions, encapsulations, abstraction, inheritance, polymorphism. So these are some of the traits which is we are discussing about the object oriented programming and the functional programming. So it is just a simple example which show for the primary constructor. Here it's a self-explanatory, and it creates a class. It defined say hi and it print a message. And in the constructor, when we are calling new greeter, and the greeter, you can change the message and then again call that class. So these constructors are in a pretty in a way you can terms of just way how it is defined in the Scala. The other thing is which you can do is the singleton and the companion objects. So this is Scala class. Let me just highlight. Scala classes cannot have static variables, right, or methods. Instead, a Scala class can have what is called singleton object, or sometime a companion object. So they cannot have static variables or method. So they have the singleton objects or sometimes companion objects. So what are the singleton object is declared using the object keyword, and how you can do that? Object main, and then in the define say hi, and then print hi. So that is the singleton object defined in Scala. And what is the companion object? When a singleton object is named the same as class, it is called a companion object. So if you see, a companion object must be defined inside the same source file as the class, and this is the example of companion object. So what is our class main? We are defining this object, say hello world, and we are printing the hello world. Now in the object, what we are doing is object is main, and we are defining it is within the same class, defining say hi and printing hi. So if you see the class name and object name which is same, it means these are the companion objects, singleton objects and the companion objects. That is the two main concept which is tried to, I think you need to remember in the Scala. There is another things which in Scala you can have is the case classes. When you declare a class, the Scala compiler does the following for that. Create a class and its companion object. Add natural implementation of hash codes, equals, and two strings. So that since that double equal sign in Scala always delegate to equals, that means that the case class instance are always compared structurally, useful for the data in transfer objects. So that is what we are doing for the case classes. So this is singleton, companion object, case classes. These are some of the features which is compared to the different from the object oriented programming that you might need to learn. Let's go to the inheritance. Is an object oriented concept which is used to reusability of the code. You can achieve inheritance by using existing keyword. To achieve inheritance, a class must extend to the other class. A class which is extended called super or parent class, and a class which extend class is called a derived or base class. So this is the basic concept of the your derived class or your super class or your parent class. So what we have done here is the class employee. It is defined variable salary, which is a float. float type, and we define the 10,000. Float means you can define in the decimals also up to a certain places. Now we have defined another class, programmer extends the employee class, and we define the bonus in this. So variable bonus integer 5,000, and we wanted to print the salary plus print the bonus. Now we define an object which will be now inheritance, which we are trying to show here, the main object. And what is saying the defined main argument array of strings and new programmer. So when we define a new programmer, it will automatically create a employee with which is the variable salary of 10,000 with initial bonus of 5,000, and it will print that salary. So we define a employee class, we define a programmer class which extends the employee class. So here programmer class is the derived class or of the, and employee is the base class or the parent class. Now the last thing which I wanted to discuss before, I think these are some of the concepts. A traits can be used just like a Java interface. As with the interface, just define the method in your trait that you want to extending class to implement. So that is the way we define the trait in the Scala code. So now if we go back, so what is the functional programming? So functional programming is a style of programming which models computation as the evaluation of expression. So what that means is functional programming requires that functions are first class, which means that they are treated like any other value and can be passed as argument to other functions or to be returned as result of a function. Being first class also means that it is possible to define and manipulate functions from within other functions. So that is the main concept of the programming. You can treat function as any other primary values. The second thing is the operation of a program should map input values to output values rather than change data in place. This result is immutable data structure. So on the program map, what output values so now what we did is that the immutable data structure is the one of the things that why I think RDD data frame data set, which is in the Apache Spark, which you have seen that like the way they are changing is the RDD is changing one shape to another, and that is like you see the how they are linking. If you will compare the whole Scala the paradigm and how this language is constructed and how it can be benefited, you see in the Spark when you are creating RDD, you see all those the way it is changing, going one RDD to another RDD to another RDD. So more things why it explain the immutable, because the whole Scala language provide a fastest and the easiest way to do that. Although there is the other programming language like Python also provide that, but again that is the performance of Python is not equivalent to what is as it is has been done in Scala. So now let's come back to the features. There are the immutability is the one of the things which is in the Scala. High order functions that you already saw that in the Scala. The lazy loading that we talked about. Pattern matching, that is also querying and partial applications, and monads. So these are some of the features which you can just look around and that explain the functional programming. So now we will go back to in Scala. Functions are first class citizens, which means you can treat it like a variable, pass it to functions, return it from function, and assign to a variable. High order functions are applications of the first class citizenship. They are functions that at least takes as any function as a parameter or return a function.